Okay, are we live? Hello? Hello? I don't know how I'm doing in terms of the gain. I don't want to talk too loudly. I don't even remember what I did yesterday. Oh, right, no, I recall. I don't recall what I did yesterday. Yeah, I was kept my voice pretty low. I don't know, I'll try to keep my voice somewhat low today too. So hello and welcome. Hope you're doing well. I just want to solve another problem here. Let's see. So let's get to it. Let's just get right into it. Okay. Given a string S, return all the palindromic permutations without duplicates of it. Return an empty list if no palindromic permutation could be formed. A, B, A, B, B, A, B, A, B, A, B, C. Excuse me, empty. Excuse me. So for a question like this, there's a few things to consider. So the first thing that comes to mind is with palindromes. Basically, a palindrome is you could take the middle of it. Actually, I guess the definition would be it's the same string left to right as it is right to left. So if you reverse the string, it's the same string. That's probably the easiest way to explain what a palindrome is. And what we probably want to do is generate all the palindromes here. That's actually what they're asking for. So all the possible palindromes. And a couple things to note. So it looks like you cannot have any palindromes if the number of characters you're dealing with, if you take the frequency map of all the characters for this string, basically just count the number of characters for each character, right? That's sort of what the frequency map is. So like there's 2 A's, 2 B's, 1 A, 1 B, 1 C, right? Depending on what you're looking at. It looks like if you have more than one odd frequency, then you won't be able to build any palindromes because the characters need to be equal on because reversing the string, you sort of have this notion of like a left side and a right side where it's symmetric. There's this notion of symmetry. There's sort of a left side and a right side, and you could have only even characters in which half of them on the left, half of them on the right, or you could have one odd frequency where one character is right in the middle and then the rest are on the left or the right. The even number on the left, even number on the, or an equal number on the left as there is on the right. But if you have two odd frequencies, then there's an extra character on the left or the right side that you can't match with another character because it's odd, right? So that seems to be a pretty obvious thing, is that you could basically it's a sort of an edge case where, well, if you have that, then you can't make any of these permutations. Now, how significant is that, or important? It's kind of a minor point, I think. The next thing we want to do is probably take a look at probably look at how do you actually generate all of these strings. And what I would suggest is actually let's consider the case where we don't have any odd numbers at all, or any odd any odd number and any odd frequencies of the characters at all. Let's think about it that way. If we only had, so basically our string is always going to be symmetric from left to right. There's sort of like a string you build and then you can reverse it and append it to the other side. In that case, actually, every string, if you divide all of your frequencies in half and you have this sort of character count of each of these characters, I would suggest that every possible permutation of those characters works, and all you have to do is just copy it across whatever that permutation is to the other side. And so you can actually just build a string and then use that to produce all the permutations of that string. And then for each of those permutations, you just copy the same string across. Now, obviously that gets a little bit funky if you're dealing with if there's an odd number somewhere in there. So all of the there's only going to be one odd number at most, right? So there's no odd numbers. What I just described is sufficient. If there is an odd number, that has to be at the centerpiece on the right side. It has to always be there. So basically, you can just remove. You could just do the same algorithm except append. You know, take that odd number, subtract 1 before you do your division by 2. Take that one character, should hold on to that, and then before you copy across all of your strings, sort of this reversed copy, you just plug in that character right in the middle as sort of the centerpiece. And that's it, I think. That's pretty much it. I think that's sufficient. I think that'll solve the problem. So let's try to do that then. So let's build a frequency map first. Start with that. So kind of complicated, somewhat complicated approach, but it's not too bad. You know, shouldn't be too hard to code it. So it's going to be character to int, and we're going to say frequency. We're going to say for auto CS. We're going to say frequency of C plus C++. We're going to say so build frequency map. There are more than one odd frequencies. No palindrome permutations exist. So we say int c just count equals 0 for auto p in frequency. Say if p dot second modulo 2 equals 1. Increment the count. If count is greater than 1, return empty. Just gotta use a empty return vector. I want to say if you have So if count is 1, we'll handle 1 approach. If count is not 1, okay. So we're gonna rewrite the code, but suppose for a moment all of, you know, no, we'll do it this way first. So we'll do it this way. Just thinking. We could do it this way. Center. Say if count equals 1, and we'll say we're going to find that one again. Just add that character. Count as 1 to the center. And then we're also going to we're going to actually decrement it by 1 as well before we do the next operation. And now actually divide it by 2. You can actually do something fancy. If you dividing by 2, there's also a bit shift to the right by 1. So everything gets bit shifted to the right by 1. So divide frequencies by 2 and remove the center character. We'll record the center character or store, save. All right, yeah, so save the center character, remove it from the frequencies, and divide all the frequencies by 2. So we do that. Now we want to actually build permutations, build all of the permutations from the character set. So how do we want to do this? What's interesting about this is also we want permutations without duplicates. In other words, if 2 characters A and A, like we could put, you could label them like A sub 1 and A sub 2. There's like a string where A sub 1 and A sub 2 are in positions I and J, and then you could have them reversed where A sub 2 is in position I and A sub 1 is in position J, where the 2 positions are switched, but it's the same string. And we don't want to have we don't want to produce those duplicates. So it's actually going to be permutations without duplicates, which is kind of tricky. Not exactly sure how to do that, at least not offhand. I can tell you how to calculate how many there's going to be. I can tell you how to calculate it. it's basically the sum of all the frequencies after we divide by 2, take the factorial of that whole thing, and then divide by each frequency, take the factorial of each one, and then divide each one of those out. That's how many there's going to be. But how do you actually produce all of those? That's a good question. That's a good question. Well, we're definitely going to use like a kind of a search, like probably a depth first search. This on the state. I guess what you could do is you pick a character, move it from your frequency set, character set, frequency set. Add that that's the first, have a string stream, I guess, stack really, string stream. Set that character, add that character, and then push that character, and then so you pick a character, and you pick any of the characters that you haven't used yet, that you have more to use, and I think what's significant or important here is to you're not going to, you're going to consider each character selection with regard to each character unique, if that makes sense. In other words, you're not just going to pick a sub 1 or a sub 2, right? In other words, if you just took a string of characters and assumed all of them are different characters and got all the permutations, that's not the same thing as considering basically considering the frequency of the character. I mean, I think because we're using the frequency map, it's going to be easier to do this. We're going to be able to do this correctly the first time. Modify the frequency each time. Yeah, I think that's the right way to do it. Yeah, I think so. So yeah, so I think I know what to do. So we're going to use depth first search. It's going to look something like this. We're going to turn ret at the end of it. We're going to use this frequency map. Call it F. We are going to modify it. Actually, that's going to be our state that we're going to use, or part of the state. And we're going to have a few things. So you have a base case, and that's if you really don't need a base case, actually. Well, you're going to have this string stream that you keep using. Really, the state could just be kind of, you don't even need this frequency map. I mean, the whole thing is sort of, you do need this F though. I'll explain that in a second. But string stream. You need or want sort of our stack that we're going to be working with. It's actually really simple. So the only thing that we really need is, I guess, the character count. I guess that's really, I guess that's, we do it that way. And we can just do a sum over, we'll just do it this way. And I want to say if ss.string.size equals character count, then ret.pushback ss.string.size or string, and then return. Basically, you've used all the characters, and you're going to do a loop over every pair in the frequency map. You're going to say if p.second is greater than 0, then you're going to f with f. Yeah, you're going to def for search again. What you're going to do is you're going to say take your frequency or frequency map. You're going to decrement minus equals 1. After the recursion, you're actually going to add the character back, by the way. And you're going to say string stream. You're going to push this character to the left side, and here you're going to pop the character. Now, I don't know if you could do that with string streams. Let me just see. Let me just test something here. Oh. Oops. I don't know if you can actually do it this way, the way that I'd like to do it. Could try it though, find out. Whoops. All right, just want to see something here. Do that frequently. Oh, okay. Can you do that? Do you need to have? Okay, interesting. So, so you can push A in when you push SS into T, though. You print the string stream. It doesn't. You don't remove that character, which is kind of interesting. So maybe a pop we can use, or pop back. No, so we don't really want that, do we? Can just do regular string, I guess. Do it this way. What does that look like? Oh. Okay, that's what we want. Yeah, so use a regular string then. That's fine. Yeah, it should be fine. What is Can we do this? I don't think it works. No, it doesn't. Okay, you can do that with strings. Gotta be careful with string manipulation though. It's like very, can be a very tricky thing. The problem with string manipulation is that you end up with you can end up with copying a lot of things that you're not supposed to copy. End up really slowing your code down a lot. Like that's string manipulation is kind of a tricky thing. You can do you know what we can do instead of a string? We can actually just do character, a vector of characters instead of a string. So a string stream we can do, and then convert that to a string later. Convert those to strings later. Yeah, it should be fine. Just thinking. Okay. Just thinking, how do we convert the vector to a string? Could use a string stream, I guess. Stop messing with my kneecap here. Okay, anyway. All right. I don't know if this is the right way to do it. I feel like this is maybe kind of awkward, but I want to avoid using string operations. It's really simple, this routine. So DFS ret should have a whole bunch of a result we'll use. An intermediate result. A vector of character vectors. And yeah, push back a copy of SS. Okay. Okay, now we want to okay, mirror each character vector appropriately and build the corresponding strings to return. Okay, so we're going to go for auto reference, call it just SS in the result. We're going to say standard do character vector. We're going to say for I don't know, auto it equals cv.begin, it not equal to cv.end plus it, ss it, if center not equal to, then we'll ss center, and then we do the other way around, which by the way, I'm going to go ahead and string stream, I don't know, vector of strings return. We go CV or begin, reverse end, dot pushback string, and then s string, empty that string stream before we use it again. We'll have to create it once. That's it. Let's see if it compiles. Warning. Error. What? Oh. All right. Could do this. I don't know, because center could be filled with junk, right? Let's make it 0. I just don't like having, I like the checks that I do, the logic that I have, I like it to be like very direct, you know? In other words, I have this thing going on here where I'm only setting the count and the character, like I'm setting the character and the count in tandem, and I know that the center character won't have anything if the count's not 1. But I don't want to just check the count. I want to check, because that's like sort of artificially, like I've imposed that like these are how these things are going to be related to each other. I would want to just check the character directly, and that way the logic is clear. So yeah, I'm trying to get that to jive, but struggling with that. But SS. Well, I don't know. Just call new string. New SS. I'm not really sure what I want to call it. I like to keep my variable names kind of short. I don't know. I used to be all about like very verbose variable names, but it just takes so much time to write all of it. Something like that. It's like Not that it takes too much time to write all of it, but it kind of does. It takes a while to just write all of it, and you really don't need to be that expressive each. You don't need to have the variables. Really don't need to be that. If it's kind of clear from the context what it's supposed to be, you don't really need that much. All right. Anyway, so what's this count? Oh, duh. I don't know. I was gonna say. I was like, how come? Of course. Gotta actually call that function now. That def for search. If you don't call it, then it won't do anything. Output BB AA AA BB. Okay. Interesting. This didn't. What happened? This is supposed to modify the frequencies. Did this not do what I think it does? Oh. Oh, I see. This is supposed to happen anyway. Yeah, no, this is... So 1 or 0, if it's... Yeah, okay, no, never mind. There we go. Okay, I see the problem. Yeah, my logic was a little bit off here. I was thinking like, oh, okay, well, if there's one centerpiece in there, then do this, and if there's no centerpiece, do that. But actually, this handles both cases, the logic here. So, because between this and this, we know that there can't be more than one, so it's either 0 or 1, and if there's 0, then this never fires, and if there's 1, then this fires, and that's it. That's all we need. All right. Just run some tests, see how we do. Yeah, so this C's got to be in the middle. Empty, single character, 3 characters, and then a whole mess of stuff. Let's see. 1A, 2A, 3A, 4A, 1D, 2D, 3D, 4D, 1S, 2S, 3S, 4S, 1L, 2L, 3L. I can go through that, 3 Ls. 1K, 2K, 3K, 4K, 1J, 2J, 3J, 4J, 1F, 2F, 3F, 2F, 1, S we did already, A we did already, L, K, D, J. I think we did everything, all of these. Let's see how we do on that last one. That last one, I may have missed a character or two. I may have missed some things. Time limit exceeded. No, you're kidding me, really? No, say it ain't so. Say it ain't so. No. Oh, it's way too hard if it's if the time limit on this is serious, then this is gonna be impossible. There are so many of these palindromes. No, come on. I can't do it. It's not gonna happen. Oh no. Uh-oh. Move a couple J's, couple K's, couple D's, couple A's. How about that? Please tell me that's not too bad. There's a lot of these palindromes, man. There are a lot. 48 milliseconds on that last one, okay. So we got there. Let's add another F. Yeah, this is very exponential. The number of these palindromes, these permutations. There's a lot of them. Okay. We add another F. Then we add GG. 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 Output limit exceeded. Wow. Really? Really? Yeah. It adds a lot. So 200 milliseconds. And we add the G and the G there. It'll just be way too much. You can add an F and F there, I think. I think that won't be too bad. But it's a lot. Should be like a few seconds instead of a few milliseconds. A couple hundred milliseconds should be like a few thousand seconds. Wrong. No. What? What do you mean it's wrong? No. Oh, you gotta be kidding me. Oh, this diff button just broke. It just broke my computer. Are we still streaming? Did it break the stream? Look at this diff button. I click it, it's non-responsive. It's gone. It's done. That's it. That's it for the diff. The diff is like, What happened? What happened? Okay, it's 2 at the bottom. All right, so let's remove this one. Hold off on this one. Okay, let's take this guy. Let's see, does that work? What do we got here? Okay, that's fine. The very last one, that's okay. But if we add another F, this should give us a problem. Right, no, that's fine. Empty. But now if we add one more F in there, really testing the limits here. It says we get an error on this last one. Let's see why. Let's see what happens. Wrong answer. Really? Really? The question is why. Also, I'm getting, what is it? I'm on vacation for my job. So you notice I'm getting a phone call, but I don't know who it is or what it is, but it's usually spam anyway. But now this is interesting. This says we have the wrong answer. Well, what's the right answer? Can we get this diff? I want to say, I think the reason What does that do? If you're using global variables or C++, check this out. Interesting. Okay. Can I get back to what I was doing? Alright, so they're saying that these are all wrong. Okay. A whole bunch of these are just wrong. Let's turn the diff off. Is this wrong? Are you sure? Are you sure? I mean, they're saying it's flat out wrong. Now, I would say I don't agree, right? I don't agree. J, K, K. I think the issue is I think it's just having a hard time with it. Just a gigantic output. Just can't handle the output. The output's just way too big to reconcile. F and F, two Fs, two Fs, two S's, a D, an A. That is definitely a palindrome. Now, how many Fs do we have? How many A's do we have? One. So now is this a permutation? What is going on? I can spam with calls today. We're gonna go ahead and J, L, 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 1, 2, 3, 4, 5 Fs, 1, 2, 3, 4, 5 Fs, A, D, SS, SS, SAK, AK, S, F, K, S, J, D. Aha! So this is definitely an answer. So they're having a hard time. This solution here, this testing portion is just, I think the output is just way too big. But yeah, it's gigantic output for this. So let's see how we do when we submit it. Let's just see how we do when we submit it. I'm curious to see what happens. Oh, there you go. 100% of all the solutions. Nice. Super efficient, super fast. Hey, I like that. I like that. Took a while. We got there. How do we do? 50 minutes it took though. Oh, 48 minutes. Wow. Wow, that's a lot of minutes. I don't know, man. I don't know if I could do that faster than that. That's probably as fast as I could do it. Like, I've seen questions like this before. I kind of stumble and fumble a little bit with regard to, like, should I use a string stream? Should I use a string? Should I use a vector, character vector? Like, what do I want to do? But obviously I got the most efficient, probably the most efficient way to do it. Yeah, you want to really avoid too many string operations directly on strings, and you want yeah, a vector for character vectors. I think is not bad. Depth first search is really straightforward. This is like a pretty efficient way to do it, I guess. It's more efficient than anyone else came up with, I guess, or as efficient. Yeah. All right, let me go. Thank you all for watching. Talk to you soon. That'll be it for this video. I'm going to go ahead and take a break. Oh, no, didn't mean to do that. Oh, hopefully you can still see me. Oh, no, you can't. Oh, no, there it goes. All right. That's always good. Yeah, the plan is take a quick break. hang out for a minute or two, I guess. And I don't know if I want to make food or want to hang out. I don't know what I want to do. I don't know what I want to do exactly. I think what I'll go ahead and do is just end this stream. Take a few minutes, come back and do another problem. I think that's what we'll do. So yeah, thanks again for watching.